Lesson 6-5, which is entitled The Angles of a Triangle. I know the sum of the angles of a triangle is 180 degrees, and I know an exterior angle of a triangle is equal to the sum of the remote interior angles. And so as you probably can guess by now, that we are going to be taking something that we've already talked about, and we are going to be expanding on it a little bit further. Let's start off what we know from pre-algebra, what we know from already chapter 1 from from geometry. But the sum of the angles of a triangle is equal to 180 degrees. And so if I take angle A plus angle B plus angle C, all of those add up to 180 degrees. Now from that theorem we get our first corollary, which is if two angles of one triangle are equal to two angles of another triangle, the third angles are equal to each other. And so if I take a look at these two triangles that are here, and I know that angle E and angle L both equal 102, let's take the left triangle for example, because do I know basically the angles of the other two? If they're equal to each other, not quite sure. But if I take the triangle on the left and I add the two angles together, I would get 132, which if I then basically would take 180 and subtract out 132, I would get 48 as my angle G. Now from that situation, you would then be able to say that basically if I know that two angles of one triangle are equal to two angles of the other, so angle E is equal to angle L, and G, which we found out to be 48, is equal to N, we would know that our final M would then be equal to angle F over here. So angle M would be equal to 30. Kind of a proof that's involved with that. So given that in A, B, and C, and D, E, and F, that angle A is equal to angle D, and angle B is equal to angle E, I want you to prove to me that theorem and that corollary is actually true, and basically proving that if I know that these two are equal, then I know that the last set would be equal as well. And so we're going to prove that here now. And so I have it set up there just up on top so you're able to see it. But let's kind of go through the steps that are involved with how to actually prove that to be true. And so if I go through angle A plus angle B plus angle C is equal to 180, and angle D plus angle E plus angle F is also equal to 180, why am I able to conclude that? So I want you to try to take a guess on your paper. If you need to pause it, all right, that's fine. But then be able to write down to me, all right, number one, why is that statement to be true? And so hopefully as you think about it, you're thinking to yourself, okay, well, I know that based off of the theorem that we just had before, which is the sum of the interior angles of a triangle, is 180 degrees. That's that first theorem that we just talked about today. That's why both of them already add up to it. Now, it also then follows from there that I would know that angle A plus angle B plus angle C is equal to angle D plus angle E plus angle F. And so I want you to be able to tell me why. So again, pause it if you need to, but take a guess as to why you think those two things are true. Based on what I did in number one, if I know that this set here of three angles is equal to 180 degrees, and I know that this set is also equal to 180 degrees, I should be able to conclude that they are equal to each other, and how I'm able to do that is through substitution. I'm substituting in something that's equivalent to 180 degrees, which is D, E, and F, into this first equation here. From there, because I know that angle A is equal to angle D and angle B is equal to angle E, it then would follow that angle D plus angle E plus angle C is equal to angle D plus angle E plus angle F. And so again, why is that true? So taking a look at step number 2, all right, why I'm able to then basically take out A and take out B and replace them with something that is equivalent to it. Hopefully, again, you said that it is, again, substitution, because I'm replacing A with D and I'm replacing B with E. From there, I should be able to conclude that angle C is equal to angle F. And so again, don't prove it by quoting the first corollary that we had. It's a why from step number 3 am I then able to basically simplify the left side to just angle C and simplify the right side to just F. And so hopefully you're thinking to yourself, okay, let's see here, I took away a D from here, and I took away a D from here, and I took away an E from here, and I took away an E from the right side. And so that would be subtraction. That would allow me to then be able to conclude that angle C is equal to angle F. Our second corollary that we have is the acute angles of a right triangle are complementary, which basically means, again, if all of them add up to 180 degrees and I know that one of them is a 90-degree right angle, I would be able to quote that the other two then would add up to 90 degrees because it has to complete the equation. And so if they both have to add up to 90, that means that those two angles are complementary to each other. Third corollary would then be able to, as you probably would guess, that each angle of an equilateral triangle is 60 degrees. Again, if all of them are equal, that means that 3 times one of the angles would be equal to 180 degrees, and 180 divided by 3 is equal to 60. Last theorem that we have, an exterior angle of a triangle is equal to the sum of the remote interior angles. So this is kind of based off of one of the previous chapters that we had in which we were dealing with exterior angles, in which we were able to say, quote, that angle 3 is basically greater than angle 2, and angle 3 is also then greater than angle 1 as well. So an exterior angle of a triangle is greater than one of the basically remote interior angles as well. And so as you probably guessed when we were actually doing that chapter as well, it's because they're actually 3 is greater than 2 and 3 is greater than 1, but we also then can conclude that actually angle 1 plus angle 2 is actually equal to this exterior angle. Now the reason for that is, again, think about it in terms of our first theorem, which was the interior angles add up to 180 degrees, which means that if I do angle 1 plus angle 2 plus this other interior angle, that would equal 180. Now if you also think about it as here is a linear pair relating angle 3 and our interior angle here, which also adds up to 180. And so if I basically would subtract out this angle from both of those equations, I would be left with angle 3 is equal to angle 1 and angle 2. And we'll talk about that probably next class period as well. And so what I'd like you to do is I'd like you to actually try this proof for me. And I would like you to go through. So in triangle, we have triangle ABC and we have triangle ADE. We also then know that angle ADE is equal to angle B. I would like you to prove to me that that angle AED, so this angle here, is equal to C. And so if we are going to prove it, I'm going to help you out initially, and then I would like you to try to finish off the proof on your own once you have some idea, because again, I want you to be able to start somewhere and have a direction for then practicing later on. As always with our proofs, we always start with our givens. And so I'm going to start with that angle ADE is equal to angle B. And why is that true? Well, obviously it's because it's given. Alright, and you probably guessed that right away, and you probably already had that written down. My suggestion to you is having this drawing actually on your proof itself, because again, and I know I keep saying it all the time, is that you're then able to then draw in your different steps along the way, which then gives you a little bit more of a visual. So what I'm going to do is I'm going to just put a little swoop around ADE and B to then be able to help me be able to kind of visualize what I'm getting at here. Okay. Now, again, I want to prove that this angle here is equal to this angle here, and so I want to probably use what I've already learned so far today, thinking back, looking at those different proofs that or those corollaries and those theorems that we've had, is how would I be able to prove that those angles are truly equal to each other? And so there's going to be 2 more steps, 2 more statements, and 2 more reasons that go along with those 2 statements that are going to be the rest of the proof. And I want you to try to think about as what do these 2 triangles have in common? That's going to be your next step, and then you're going to be able to conclude something from there. And so I want you to try again. It's only 2 more steps, and so I want to see what you guys come up with for our next class period. Thanks for listening again, and we'll see you next time.